Right, let's look at Snell's law and refraction for A-level. So this is a bit more complex, and very often students struggle with this. So this is the formula that we're given in the formula booklet. N1 sine theta 1 equals N2 sine theta 2. So N1 and N2 are the two refractive indices. So the first refractive index, the second refractive index. And then theta 1 is our first angle, theta 2 is our second angle. So this, as shown here, this would be the angle of incidence and the angle of refraction. So this is a more general approach. At GCSE, we always assume that one of those materials is air. And the reason why is the value of refractive index of air is 1. So that would simplify, and we just get rid of N1 entirely. So we end up with sine theta 1 equals N2 sine theta 2, which is basically the GCSE version of Snell's law, because we've always got one of the materials with a refractive index of 1. So at A level, well, it could be 2, it could be water and glass, or it could be diamond and perspex, or any other scenario. And we've also got something similar for the ratio of velocities. So again, rather than M1 always being equal to 1, and we find the refractive index of the other material, it's actually N1 multiplied by V1 equals N2 times by V2. So a little bit more complex. So let's look at some worked examples. Right, so let's look at this worked example. So we've got two materials, glass and some other material, which we don't know what it is. So it's always worthwhile doing a little sketch. So N1 is our first material, 1.49. N2 is the unknown. We're going to have to find that in part A. And we're told the angle of incidence is 28, the angle of refraction is 41. Okay, so we cannot use our GCSE version of Snell's law. We have to use this expression here. So it's worthwhile writing out what all these values are. So N1 we know, N2 we don't, theta 1 we know, theta 2 we know. So if we write out this expression we're given from the formula booklet, we're trying to find the refractive index of the second material, N2. So take sine theta 2 from the top to the bottom on the other side. And once we've got this, it's just a case of substitution. We can put all the numbers in and we get N2 as 1.07, which sounds about right. And if you think about it, it should make sense because we've got an increase in this angle here. The angle of refraction is larger than the angle of incidence, which would suggest that the light has speeded up, which means that the refractive index should be less than the previous one. And if we're trying to find the speed of light in the second material, then we can use this new expression here. Make V2, that's the velocity in the second material, the subject. So it's N1 V1 over N2. And again, we can just substitute the values and we get 2.79 times 10 to the 8, which is what we expect because we're told in the first material it's 2 times 10 to the 8. So it should be speeding up in the second material, which is why the ray of light bends away from the normal. So a little bit more complex, but far more versatile because we can use this for any combination of materials, not just one material and air.